we should be able to just go, and then we'll deal with it. We'll never have Miblo. No, but we'll
we'll buy a Miblo a new computer where he can install Windows 7 or
yeah.
something.
Well,
Hi, folks.
hello. Hello, everybody, and welcome to an episode of Handmade After Dark. Despite many technical problems to get this thing off the road, it's totally not because of Miblo and his Linuxness. It is.
Yeah.
No, but I am your host, Mikkel Hjortshoej, known by many names, but I prefer this drunk Dane because beer. I'm joined by Alan Webster. Welcome back.
Hello.
And I'm joined by, well, I don't know how to say your actual name or your last name, so I'm just gonna say hello, Miblo, our little Antasian prince.
Hello, F-Ucon. Or this drunk Dane. Or Mikkel Hjortshoej.
Yeah, that's
Is that at all correct?
no.
Nowhere near.
Okay, so it's been a while since the last episode, about a month or two. Many things has happened beside this, and the most exciting thing personally is all of us went to Handmade Con 2016, all the way back in November. Before we get into what happened during the con, there's so many exciting things. Firstly, did you guys also get sick or right after we came back?
I did, yeah.
I did I get sick? I remember seeing that everyone was posting that they were getting sick, and I don't remember for sure that I actually got sick, but I I don't know. I feel like I had placebo effect sickness. I can't remember the actual word for it. But, I started going, oh man, am I sick? And then about a day later, no, I'm okay.
Yeah, sort of vicarious illness.
Mm-hmm. Yes, exactly.
I was very sick for 2 or 3 days, and my voice itself was shut until the start of January. My voice did not sound great at all. It was crackly, at least deeper. But it was gone for sure, which is one of the reasons why it's been so long since the last episode. And we're only 3 people here today because apparently Zach was supposed to join us, but apparently his internet...
his technical difficulties were even worse than the ones that kept us from getting started for several hours. Yeah.
Yes.
Yeah.
Indeed. So,
how late are we?
It's now 2.5 hours.
Hey, it's only half an hour if we go by the original schedule before I asked us to start early.
Yeah, so you only have about 2 hours left before you have to go. Yeah. Anyway, so we went to Handmade Con, which is of course the wonderful convention hosted by Casey Muratori, where we basically took up a bunch of people on stage and talked and have a conversation about stuff they've done and so on. The first talk was with Jeff, and his name is of course
Fabian.
That was Fabian from Red Game Tools, and we talk about compression. I've personally never done any compression type stuff. I've of course thought about it, but never actually written anything. I know you, Miblo, you're doing some streams where you're written some compression type stuff.
That's right, yeah. Well, I've never done compression before either. It's actually Fiery Drake who suggested, while we were in Seattle, as it happens, we were just chatting about practicing stuff. Because last year I started by practicing programming in C series, which I unfortunately abandoned throughout the year. But we're talking about
I'd like to point out that the practicing programming, at least if I understand correctly, was inspired by Handmade Con 2015, where Mike Acton suggested that everyone learn how to practice.
Exactly. Yeah, that's it. Yeah. So yeah, Mike Acton's thing is to practice for 30 minutes and throw it away. So I do the throwing away part of it, but the 30 minutes, it never fits to 30 minutes. They always end up 2 hours. 2 hours is the default time.
Yeah. Okay.
So yeah, I mean, so Fire Jake had suggested that I do a run length encoder. So that was the first thing that I tried, which is kind of interesting to do.
I think it's kind of, I don't know if the right word is brave, but impressive that you're just jumping into C and trying to learn C, and now you're just I'm gonna write a compressor while learning C, Which
Yeah.
where usually you learn C by saying, okay, now we make Tic Tac Toe in the command line, and now we write Hello World to the usual kind of practice stuff. You're going like, I'm gonna practice by writing compressor.
Well, one of your first practices was figuring out how to sort something without researching how sorting algorithms work, right?
That's right. Yeah.
Oh,
And that's
wow.
very impressive too. I mean, you ended up with like a selection sort or something.
Yeah, I ended up with that. Yeah. Yeah. I mean, I suppose I'm kind of picking topics that would just enable me to learn kind of C programming and to sort of grow my little programming toolbox, really. I mean, I feel like I've sort of taken maybe kind of a logical way through it. Like, I mean, for example, Tic Tac Toe sounds like quite a complex thing. I think that's a bit more complex than actually like the run length encoder. But maybe it's actually not, and just because I haven't actually worked through it.
I think if you actually, looked at the core of what Tic Tac Toe is, like, I think in principle Tic Tac Toe is very simple, but the implementation of a Tic Tac Toe game that you could play would be this whole nasty thing of like, all right, you gotta give it input and then print stuff out, and you realize, well, actually, anytime you're doing terminal interfaces, they're quite, I don't want to say complex. It's a very nasty art to it. Like, it's not something that anyone wants to be good at, but eventually you do kind of get good at it as you program a lot. And so it might be a lot easier to figure out how to sort something and then just print out the sorted thing than it is to make an interactive tic-tac-toe interface, even though the tic-tac-toe implementation itself it's trivial. It's 9 booleans, right? Or I guess it's 9 bytes because you have 3 states each cell can be in.
Yeah, that's if you want to say, okay, I can use the cursor keys to the arrow keys to like, okay, I want to pick which one. Where I know some people, they just go, okay, you it prints out the board and you write in coordinates, okay, I want 1,3.
Yeah, but that's what I'm saying. The process of like parsing that input and like doing the back and forth in the terminal, it comes out feeling really nasty. So even if you want to feel like you've done a good job, it's like, well, I'm gonna have to get good at this terminal input output stuff, which is kind of like I don't want to learn to program doing that necessarily. I could see that being an approach. On the other hand, I do think run length compression is probably, or run length encoding is probably still more impressive, I think, as a learning experience than tic-tac-toe would have been. Yeah.
Yeah, because when you write in tic-tac-toe, you're basically just learning working with the language. You're not learning anything else really, unless you don't know how tic-tac-toe works, and then you're 3 years old or something.
Yeah.
But whereas what you're doing, you both have to learn the language and you still have to learn this concept of the compression, or you have to learn the compression algorithm itself and like at least somewhat understand it to implement it. So it's kind of, I think it's like a great feat you're doing it.
Yeah, I think that's definitely true. That you're learning C along with interesting algorithms at the same time is something that is pretty unique, I would have to say. I think
they usually
not a lot of like tutorial. Like if you were to go online and say I'll learn C in 5 easy lessons or something, it would never ever have an algorithm anywhere in it. It would just be, here's the language and like little toy things that are easy to do, how to do them in the language. Yeah. So it is interesting that you're simultaneously doing both.
Gosh, that's kind of fascinating, really, to hear that my approach is kind of unique in a way.
At least I haven't seen people take that approach before. There are probably people that have, but I've never seen it personally.
Right. Yeah, I mean, it's kind of, I think it's working for me.
I would say so. I mean, if you're doing a Burroughs-Wheeler transform now, you've made very quick progress in getting from learning C to like really being able to program something quite
useful.
Yeah.
Yeah. I mean, I'm kind of doing like every bit. So I'm doing it all from scratch, obviously, because I'm a handmade person. So it's all from scratch. So like, yeah, I'm kind of learning
I
the
have
total,
to be
like,
Abner right here. I have to be
basics of it.
very, very Abner right here and say, handmade doesn't necessarily mean that you have to code things from scratch. It just means you have to care.
Yeah.
He's been recently been very, very like this like he very clear about where the distinctions between like handmade hero and handmade network is. See, at least on Twitter, I've seen him being very like, no. This like we are not these necessarily these people only. Like it's quite funny seeing him being very like, I understand why, but still a little funny.
Mm-hmm.
Yeah.
Yeah, and like even the thing about being whether or not something is handmade, the question of is this handmade enough kind of question is something. I don't know how active he's been about that on Twitter, but I know he's talked to me a few times in sort of like, hey, how do you feel about what it means to be handmade right now? Like, do you feel like it means this or that? And trying to figure out how everyone feels about it, and if he's had the sort of messaging impact that he's wanted to have, kind of thing.
I feel the message he wants to have is it's about caring. It's not really about you can use all the fucking libraries you want as long as you care, which usually means you won't. But it just means you need to care about the underlying code. You need to care about the trade-offs. You have to understand that just coupling all these things together has some major issues, and you have to understand the consequences and still say the pros outweigh the cons in this case.
Yeah. I think it's a sort of a thing that everyone's figuring out as we go. Because I mean, there's a certain a spirit to it, like an attitude that we all kind of share in common. But it's hard to put your finger on. Do I actually care about never using a library? It's like, well, if you press me on it, no, I use STB TrueType all the time. It's almost like, is this going to have a graphical component? Yes. Okay, drop STB TrueType in right now, because I need it. And so I'm not really anti-library at all, and I can't possibly say that I am. And yet I feel like in the handmade, there's still something about being handmade that's like, you do have at least a willingness to program things that previously people might have told you, well, that you don't need to program that because there's a library. It's like, well, I'm willing to try and learn about how to replace that library.
Yeah, because there's still things you shouldn't write yourself. Like any cryptography, you shouldn't do yourself. It's like the one thing where you leave these to professionals that can.
Well, I mean, it depends what you're making. It depends what you're making it for. I mean, if you're making it as a production thing and it needs to actually work,
but I mean,
then you need to go and get the proper stuff.
Yeah, like if you're using it in commercial sense, like proper software, and this needs to actually be secure, you don't write it yourself. You find somebody who's made it because they have been peer reviewed, tested, proper like security, like cybersecurity programmers have worked on it and made it.
Yeah.
And that's.
I mean, I haven't.
What?
I've never done any encryption yet, obviously, but I imagine that it's the kind of thing that you need to put a lot of research into.
It's a lot of
a lot of
more or less
knowledge
just math.
Here, there's two things. There's two things to encryption. On the theoretical side, it's very tricky math, and not tricky as in like, oh, this math is hard to do, but like it's hard to come up with an encryption algorithm that meets the requirements of being encryption. Because to be encryption, it has to be something that is very easy for you to encode, like computationally easy, right? Not easy. Maybe it's you have to understand the math, and it's hard to learn all the math involved. But computationally, it needs to be cheap to encode the encrypted thing, because you're going to encrypt messages all the time. But it needs to be computationally hard to crack the message without the encryption key. But it needs to be computationally easy to crack the message with the key. Otherwise, you can't decode fast enough, right? So it's got a lot of weird requirements, and finding the right formulas that give you encryption on the theoretical side is tricky. But even once you've done that, doesn't matter how good your theory is, practically there's always little holes and like edge cases where if you're not clever, like, okay, you've got this really great signing system that makes sure that only this one verified person can send these in like admin messages and no one else, right? Well, what if, as a hacker, I get clever and I say, okay, well, I'm just going to wait until they've sent a message and then copy that message and send it later. And now it looks like there's the one sending the message instead of me. So now you have to learn, okay, well, we need to like put like time stamps in our messages, or we need to put you have to learn by practice, how can you attack even a perfectly secure system there are still edge cases and tricky things you can do as the hacker, and just going through the process of learning practically, there's no way to prevent someone from copying a message and resending it. So we need to do this and that. Is something you can only kind of learn by being attacked that way and then building in the defense, right? And that's why you leave it to the professionals, because they've had time to weather a bunch of attacks and beat them, right? Where even if you implement the theoretical thing correctly, practically, you haven't had the time to weather all those attacks and figure out how to handle them.
Yeah, that's why like usually like their entire cybersecurity suites, and that's why their entire programming or software companies, that's all about this is the only thing we do, because it's incredibly time consuming and hard to do the single thing, so you can actually make your entire company about that single thing and earn a lot of money. But also like just the libraries around, just okay, this is maybe only RSA encryption, but it has to be tested and peer reviewed, so, and basically every single code has to be like, is there any problem here? Can we be attacked by some software kind of attack here? No, fine, we go later. If we find some way we can do that, then we have to come up with a way that doesn't introduce a problem and can be attacked in other ways. And that's again why even you leave it to professional, but also just something that has like it's been through the test of time, and we say
exactly
this is secure, this works. That's why we use it.
Yeah, if you make your own, the problem is, even if you use the most up-to-date theoretical encryption, you don't have all the benefits of having corrected 20 problems over the last 10 years that are practical problems. And so you're going to have all the holes that hackers already know about, and they're going to know you have those holes because you wrote it yourself, right? So I
suppose, when you're learning it, you, like if you to do an encryption algorithm, you'd want to learn it in like an environment that's not like mission critical, basically. So for example, like the Handmade network IRC, you could see practicing making an encryption system that works in there, for example.
There's but yes,
I wonder if you could actually have try and work on an encryption system while another encryption system is actually doing the proper stuff, if that makes sense. Or would that kind of just complicate the whole process too much? Do you know what I mean? So like if you've got some encryptor just sitting there intercepting all the messages, encrypting them, and doing all the stuff that an encryptor does, if you had that in the middle, could you like implement your own encryptor that works around that?
Oh, so you mean let's say we're building a chat application, and okay, I built an encryption to encrypt these things, but because I'm not entirely confident in it, I'm still building on it. I also have SSL in the middle, making sure this is actually secure, but I have my own encryption-decryption pair on each side that I can work on until I'm confident in this. You talking about that?
Yeah, absolutely. Could that work?
Like it will work. I don't see the practical applications of it unless you're testing your own.
The thing it does, it allows you to test that you're properly encrypting and decrypting. Like one part of encryption is you got to be able to recover the message. It lets you test that you can do that. It doesn't really do anything to test the security, because unless you can like measure the number of times you get compromised, and the number of times you get compromised actually, like at base level, you're going to have a less secure system than SSL, right?
Yeah.
So originally, SSL will be providing all of the security in your system, and that is where you'll get like whatever level of compromise, whatever rate of compromise you normally get with that is what you will be getting, which should be close to zero, right? So it's already should be secure anyway. But if it just so happens that you do get compromised once in a while, and then eventually you notice that the rate of compromise goes down, then that would suggest that your system is now more secure than SSL, because it's providing more than what SSL was at the baseline. The only problem is if the thing in the middle is really super secure, you have to beat it to know for sure that you're more secure than it. And until you beat it, you can't know for sure that your thing is that secure. And as soon as you take out the thing in the middle.
And if you beat SSL, you can earn a lot of money.
Yeah.
Basically.
But yeah, I don't see
being
how...
white hat or black hat. Both ways you can earn a lot of money by beating SSL.
I don't. Yeah, It's true. I don't see how you could ever test security except for to risk losing information though. And the other problem with that is you have two ways of testing. You either get white hat people who try to break it for you and go, here's where you're broken, or you try to get black hat people to do it. But to get black hat people to do it, you have to put actual money for them to steal from you into the transaction, right?
Yeah.
So you have to be like, all right, we're investing $100 per transaction. If you can crack it, you get the $100, and then like go, and then maybe you can figure out how to make yourself secure that way. But it's going to cost you a lot of money either way, I think.
Yeah.
To
It'd be
secure.
interesting, like whenever the next Handmade con is, if Casey like could get some security person or people to talk, because it would be, I think it's a very different feel compared to games and general software, because they're usually a lot more focused than many other software companies. Because even if you say, okay, we're making health applications, that's still a very like wide thing where we make security layers. That's very narrow. And it would be interesting to hear about that, how it is working there, because they're also basically, if they screw up, if a game screws up, your computer crashes. If a secure layer screw up, a company can lose millions of dollars.
Yeah, it's very economic. It's very much an economic sort of arms racy kind of.
Yeah, and exactly.
Field.
It's always an arm race between making good encryption that they can not only beat the increasing computation power, but also how good hackers are getting. So it's like I think it would be nice if Casey could like bring somebody in that could talk about that sort of stuff. I think it would be very interesting to hear.
Yeah. Speaking of random things, we'd like, this is a total change in topic, but speaking of things we'd like to see in the future.
That's what this is about.
Yeah. Here's something I would like to see in the next con, which I was kind of expecting to see this con, but it didn't materialize. But I'd definitely like to see somebody who works on VR next time.
Yeah.
Okay.
I'd say it's not really interesting from a programming perspective, because there's nothing new happening. So, but somebody designing VR application and games, that would be very interesting, because it's very different.
I think new stuff is going to come out for VR. There's this thing that was on my Twitter feed a few days ago or something about VR, about how the rendering for VR has to be quite a bit different than standard rendering because of like the fact that you need to achieve very low latencies on very complicated scenes in order to prevent you from sort of getting nauseous, right? And that's forcing people to invent whole new sort of ways of thinking about rendering and doing things like lighting.
There's something called foveated rendering is not the right way to say it, but where basically you track the pupils on the eyes and you render a certain area where there's looking at full res, and everything else you render at half res.
Yeah, and that's an interesting thing. There's also this new thing that I was reading about was called the light field, which is about how to handle the fact that when you render something in like a game normal, it's not VR, you kind of don't need to think about the fact that it can be viewed from multiple angles, because even though it can be viewed from multiple angles, you won't get nauseous if you are a little bit a second of lag between when you look at that thing and when the frame comes back to you, right? But the fact that in a VR game you have to be able to respond more quickly means more stuff has to be pre-rendered, and that leads to a complicated question of how do you do lighting when the angles of where you're looking at something can change right away. And I didn't totally read how the whole thing works, but the light field is like some kind of new rendering algorithm that they're working on, or that they've made that they're trying to improve on, or something that's supposed to be able to solve that problem in a way that classical rendering can't solve it quickly enough. Which I think things like that would be interesting to see, like, oh, we've got all these new algorithms now because we have a totally different level of time constraint that even games didn't have before.
Yeah, because the use, even though I think I think it should be higher. The usual, at least for PC games, the frame rate targets to at least hit the 60 frames. That's where you want to at least be. But for VR, it's at least 90, and preferably bigger, so you can, because even in a 60 FPS game, if it sometimes drops to 50 or 40, you can live with it. In VR, you could begin to puke. You could become physically sick. So you have to always hit that 90. You can never ever dip under 90. You never ever want that. So you have to even say, okay, we actually kind of have to hit 120, so we can handle frame rate drops in case something happens. And yeah, I've seen a lot of new lighting techniques come out since VR became a thing, because that's usually one of the most expensive computations to do in rendering is lighting. And that's why I think there's a lot of innovation, especially on that field, to get that, as you say, as fast as possible from I think they call it frame to photon latency, because it's not even just the latency between getting the image to the screen, then it's the screen switching, and then the photons hitting your eye.
Right.
Because yeah, like we usually think of delay being delay as just how quickly can the image get from the graphics card to the screen, but it's also the latency of which pixel can switch, and switch and also general input delay in a screen on top of that. That we don't ever think about, but VR has to, because suddenly you can get sick if it's not low enough.
Well, one thing, this is something I've been thinking about that VR got me thinking about is there's this sort of if you take like a introduction to philosophy course, one of the things that philosophers think about is how do you know if reality is real or if you're in a matrix? Like, is there any tests to run? And basically my philosophy on that is there's two basic variations of that. There's either you were in the reality at some point in your life and now you're in the matrix, or you've always been in the matrix. And my take on it is if you've always been in the matrix, then there's no concern, because if you were born in the matrix and you live in the matrix, then you're just that's the world.
That's your reality.
That's your reality. But if you were tricked at some point in your life and put into the matrix, then you are being tricked and you should try to get out. And the good news is VR makes me think that there's no way to simulate reality at the same rate of reality, because you have to build your simulation using reality itself. So the best you could do is match it, and you can't ever, there's no such thing as zero energy systems, right? So you always have to lose a little bit of time in the simulation of reality. And so there's always got to be a little bit of latency if you're in a sort of virtual reality, right? I don't think there's any way in real reality, when you move your eyes, the time it takes for you to start seeing something new is really just the time it takes for your brain to process the information, because the photons were already on their way to you. Like the photons were on their way to you before your eyes moved. And so the only thing that it takes is the neural processing time, which you're comfortable with. You have to be, because it's always there.
Yeah. It'd be very weird if you got nauseous because of how quick, how slowly your brain processes image.
Yeah. Yeah, well, I think that you can actually get sick from that if something goes wrong, right?
Totally.
But assuming that you're healthy right now and you don't have like vertigo or something, all that should work. And so what I think about is, okay, the best you could ever do is to match reality, which is to have instantaneous switch, right?
Yeah.
And since you can't do that because you need time to simulate, there's always a test to see if you're in reality or not, which is find a way to measure the latency of the universe. Right? If the universe has any latency, then you know you're in a matrix. That's because I don't think it's possible to make a zero latency system.
Yeah.
That just doesn't make any sense. You have to build it in reality. Anyway, it's just a little philosophy.
Yeah,
philosophical thing that relates to VR. Yeah.
It makes total sense. Yeah. That now how you would measure the latency of the universe if you were in the matrix, because then any measurement you would do would also have the inherent latency.
Well, I mean, it would have to be a measurement you do in your own head and go, is like, does this feel like, there's some sort of border at which if the thing that's simulating reality has to be built in reality, right? It has to be lesser than that. It can't simulate an equally complicated and fast reality as the one that it's built in. So my thing is, because I think VR proves that there's always going to be a little bit of latency, like, that doesn't improve that. Just the way reality is proves that. But anyways, this got more philosophical than I expected. But that's something VR makes me think about.
Yeah.
Is like, I think VR kind of reminds me that because a lot of people, I don't know, a lot of people get weird about things like VR and AI, where they think like some crazy futuristic thing can happen to us where we get sucked in. And I think there's pretty real things that prevent certain apocalypses.
Yeah. Yeah, like I also think I also think people are somehow, or like somehow, some are greatly overestimating the demise of humanity by AI.
Mm-hmm.
I certainly
just before we move on to AI, I mean, are you saying that VR will prove? Well, VR cannot prove that we're not in a matrix, not in the matrix.
Okay, what I'm trying to say is VR. It's not proof because proof would be some kind of proof that shows, given any system, it's impossible to simulate. So it kind of relies on how you think about things being built. But think about like, okay, are you familiar with the game of life, like the cellular automaton kind of thing? So the interesting thing about the game of life is that it is self-hostable in the sense that you can create a logical configuration that simulates the game of life on a larger scale, right? Where you have larger grid squares, and it takes like thousands of steps in between of the small game of life for the big game of life grid to update. But then it can update and show you a new situation where a bunch of cells are turned on, a bunch of cells are turned off, and the big game of life behaves exactly like the small game of life. It just has this thousands of cycles of latency that the small game of life has to go through for one step of the big game of life, right?
Okay.
And that kind of thing, when I think about it, I don't think there's any such thing as a zero energy sort of perfect conservation of the properties of a system, right? So if you build something in a system, and the thing you build is a simulation of that original system, then this also has to do with emulation, which I'll get to. But the best you could ever do is to hit the same speed of that system, and unless you are literally using the original, right? So if you want to, you don't need to simulate game of life in life. You could just run the original game of life. And same thing with VR. You don't need to make a virtual reality. You could just set up things up in reality, right? But if you want to do certain things, like with VR, there's certain things that are hard to build in reality. It's hard to build the experience of robots, invading the bunker you're in and you shooting them. It's hard to build that in reality. So instead you do it in VR, but you have to simulate that reality within your own. You can never simulate it at the same speed and resolution as the original reality. That's my theory.
Yeah,
right.
It makes sense. Yeah.
Because anything, I mean, the only reason I have that theory is because any system we have that is self-hosting, like an emulation layer, it's always slower than the original, right? You always have to lose something in the simulation. So yeah, that's VR is kind of, it's not really a proof, but it's more of a starting point that gets you thinking about since there's this problem.
It shows you these properties.
Yeah, it shows you this property of the fact that a self-hosting system it can never simulate itself with perfect preservation of speed and resolution. Right.
Yeah.
So yeah, the sort of the idea of a matrix apocalypse I don't think is possible.
Yeah, it's
So I see what you're saying.
So yeah, guys. So people, the ones who didn't think that Handmade After Dark would ever get about philosophy, thank Alan. Yeah, but anyway, we run about a half an hour here, and just because of our delayed things, we need to get going with other episodes. So for now, this was supposed to be about Handmade Con, but became about philosophy and VR and other stuff. Basically, it embodied the Handmade After Dark spirit. So what more can I ask for? And see everybody next time.